If you've seen my last video on the quick collet chuck, you might think I have now all the work holding accessories you can dream of for a lathe. But of course, I haven't. Although I have acquired over time quite a variety of different chucks, there are still workpieces which can't be clamped with any of them. Thin discs or washers, for example, are such a case. One way would be to clamp such parts in a magnetic chuck, but who has one, and try that with stainless? Some just glue such thin parts temporarily to an arbor for machining, but I really don't like this. Instead, I decided to make a chuck which makes it possible to clamp such delicate parts. Of course, I'm not making an entire chuck here, that would be a little bit too much. I'm just modifying an off-the-shelf one into a split jaw version. What this means, you will see in a second. I searched the internet for a basic 80mm chuck to start with and found this nice looking Vattano chuck in the assortment of Ragotsky & Gaetje, which is a supplier of all different kinds of tools and machining equipment. I told them about my project and they thankfully sent me this chuck for free. So be sure to check out their web shop via the link in the video description. To my surprise, the Vattano slogan resembles me of a famous YouTuber, but I can't remember the name at the moment. So anyway, let's move on. The chuck comes with pretty standard accessory and a test certificate. A chuck key with a useless spring, 3 outside clamping jaws and some screws for mounting. On the first impression, the chuck seems to be really nice. Perhaps it's not the highest standard, but you wouldn't expect this for the price, but it's not bad either. In fact, all the surfaces are nicely ground and overall the chuck looks pretty decent. Along with the chuck, I got a set of spare soft jaws. As these jaws are not hardened, they can be turned out to adapt to a specific diameter or workpiece. I ordered this set of soft jaws to modify them into so-called base jaws, on which I can screw on soft aluminum top jaws. This type of a base and a top chuck jaw is called split jaw and often found on bigger industrial lathe chucks. And as I haven't seen an 80mm version of this chuck type, I have to make my own one. At this point, many thanks again to Ragotsky & Gaetje for generously sending me the lathe chuck and the set of spare jaws. As everything was quite oily from shipping, I had to clean all the parts first before starting the project. Of course, you can use the soft block jaws directly on your lathe chuck and adapt them to fit your workpiece. That's actually how they are supposed to be used. But my plan is to shorten the jaws, milling a profile on the top side and tapping 2 threads into each jaw to screw on the soft aluminum top jaw. For making the soft top jaws, I bought a scrap piece of 50mm thick, precisely milled aluminum plate. With this, I have all the parts for this project. As said, the spare jaws are from a softer steel, so it should be possible to machine them. The first step is to shorten the block jaws, so milling is a little bit easier. For this, the self-made saw stop is pretty handy, but you have to know how to use it. I don't know exactly why this could happen, but for the first jaw, I set the stop to the false number and actually cut the jaw too short. So the first jaw has to go to the scrap bin. The top surface of the jaw is about 1/2 millimeter too low, and that's even before it's cleaned up on the milling machine. Luckily, I noticed the mistake after the first cut, so I could at least correct the saw stop to the right measurement for the remaining 2 jaws, but the first jaw is scrapped. I told Ragotsky and Gaetier about my failure, and they were so kind to send me a set of spare block jaws again. And here you can see the right sized jaw and the too short one in comparison. The two right sized and rough sawed jaws have to be milled now to the correct height. The jaws are considered to be soft, but nonetheless the steel felt quite tough to machine. I took a short test fit on the chuck to see how deep I can go on the milling machine. With the two base jaws roughly milled to size, I decided to first finish the aluminum top jaws while waiting for the spare jaw to arrive. Again, I'm starting with roughly bringing the parts to size on the bandsaw. And these are the 4 blanks for the top jaws. Of course, I only need 3, but you never know. Now I have to mill all the blanks to the same height. These are all the 3 jaw blanks with the first side milled. I decided to use 7075 aluminum, which machines quite nicely. And now the backside has to be machined. The 3 jaw blanks all milled to the same height. Now I'm establishing one perpendicular side on each jaw. A little bit of chamfering with a hand file, and the parts are ready for milling the positioning features. I took a last finishing cut on all the jaws in the same setup, before milling a step to register the top jaws on the base jaws. It was supposed to be 8mm, but this should be okay. As the end mill was pulled out of the collet while milling, the 2 steps turned out to be a little bit too deep, so I had to take away some material from the top side to get everything back to dimensions. And that's the milled step, which registers the top jaw and also transfers the clamping force from the base jaw to the top jaw. For positioning the jaw sideways, I milled a 5mm slot along the long side. I used a gauge block to roughly measure by feel the width of the slot. If you look closely, there is a little bit of play, but that should be okay. I'm also checking the depth of the slot with my new acquired depth micrometer. It's actually a used tool, but at least it's new to my shop. Now just repeat the steps on the 2 remaining jaws, and the most nerve-wracking part is done. And these are the top jaws with all the positioning features finished machined. Now they only need mounting holes with countersinks for 2 M4 screws. To make this task easier, I installed this vice stop I made a while ago. It's a pretty simple accessory, but it's quite useful sometimes when doing repetitive work. After finding the center, I drilled at first all the holes on the right side, and in the second step all the holes on the left side. The last step is to machine all the countersinks, and the parts are finally finished. And these are the finished top aluminum soft jaws. Oops, almost finished. One side is still rough and needs to be machined nice and clean. A little bit of chamfering and the top jaws are finally done. In the meantime, the replacement jaws arrived. At this time, I carefully watched the numbers before cutting the part to length. A quick clean up on the milling machine, and I have all the 3 base jaws ready for further machining. For bringing the base jaws all to the exact same height, I'm remounting the jaws to the chuck and the chuck to the lathe. In this way I can face the top side of the jaws with a lathe tool. I inserted a piece of steel rod for preloading the jaws before taking the cut. At first I tried to cut the jaws with a polished insert for aluminum, but the steel is pretty tough, so I changed to a different turning tool. Just for the last finishing pass, I changed back to the polished insert. I deburred the edges with a small stone before further machining. Now the base jaws need an 8mm slot milled into them according to the soft top jaws I made earlier. I took really light passes here to not overstrain the small milling machine. I'm checking the depth at first before widening the slot to the right dimension. A first test fit with one of the top jaws, and the slot seems to be still a little bit too tight. And no surprise, the gauge block won't fit at all. So I took a little bit off each side until the gauge block fit. The gauge block now kinda fits. It doesn't go all the way in, but as the step on the top jaws is a little bit under 8mm, the fit will be okay. Now I have to mill a step on each side for the sideways registration. I had to be very careful here, as I wanted to have a very tight tolerance fit between the base jaw and the top jaw. And these are the 3 base jaws with all the milling work done. I have to say, they came out pretty nice. I'm really happy with the fits and tolerances I managed to get on these parts. The top jaws fit with a light press fit. I copied the design from the bigger industrial chucks, and I think the parts are starting to look pretty professional now. The only thing left to do is drilling and tapping 2 holes for 2 M4 screws in the base jaws. Drilling the steel was surprisingly easy, but tapping was a little bit nerve-wracking. I just carefully started the threads on the milling machine and finished them by hand later. This way they came out nice and straight. And here are the 3 finished base jaws. I'm pretty happy with how they turned out, and especially that I didn't break a tab in one of the parts. And now we have all the parts together for final assembly. 3 base jaws, 3 top jaws and 6 M4 screws. I have to say, no matter how useful this chuck will be in the future, I really do like the look of it. So, at least for optic reasons, I think it was worth the effort. And now back to the washer from the beginning. I will turn a recess in the front side of the jaws about the same diameter as the washer to clamp it for a facing cut. To preload the jaws while turning, I inserted a piece of 10mm round steel bar. And yes, with a left-handed boring tool you should reverse the spindle speed as well. It cuts much better now. The whole thing of this split jaw story is that, at least in theory, you can screw everything you want onto the base jaws and modify the top jaws to all different shapes and sizes. This will allow you to clamp odd-shaped or very delicate parts, which are otherwise impossible or very hard to clamp with a normal lathe chuck. That will make this chuck very versatile and useful. The washer has slightly beveled edges and gets pushed out of the jaws, so better turn it around. But even with that done, it felt like a really sketchy setup, but no risk, no fun. Let's try it out if it works. Of course, I only took really light cuts, but so far the chuck seems to work and the jaws seem to hold the washer as they are supposed to. The finish isn't great on this stainless steel washer, but that's not the topic here. In conclusion, I will call this project a success. We will see how this chuck will be used in the future, so stay tuned, thank you all for watching, and till next.